Okay. Okay. So here I have compiled, right? But what happens here? Which is this cuboid.class file? I don't have two cuboid.class files now. This bytecode for only one. So what do we do? If I have got two separate cuboid classes, right? The name is cuboid. How will I distinguish them? By using a prefix. I should have some different prefix for it. Right? That is nothing but we should go for, what is it? They should be having different prefix. How do we specify prefix for any class definition? Okay, so we can just say, what's the declaration? How do I say what is the prefix for the cuboid composition? Package. And you can just say package com. So now we have a class. What is the name of this class? Yeah. Okay. Fine. What's the purpose of a packet declaration? To have a prefix for the class. Okay. Okay, fine. So we can even go back to the earlier cuboid, which was there. Yeah, where is that other cuboid? Oh, we have the earlier cuboid also. And maybe here also we might like to keep a prefix. Okay, let's call it shapes. Okay. Or shapes where I'm using inheritance. Let me just say. Okay. So this is the inheritance version of keyboard. Okay. I'll just save it wherever it is saved, and it's still okay with me. Okay. But then, what about this class called test cuboid? Should it have the same prefix? So one thing what we have to now do is shift this out of the file. It should be in a separate file. Okay, fine. It's a class called test cuboid. What is the prefix which would be preferable here? Okay, just cut it and then going for a new file here. Yeah, let me paste it here. Okay, so this is the test cuboid, but yes, what do we use here? What's the prefix? For test cuboid, we might like to keep prefix as test. So this becomes, this is nothing but a test cuboid. Okay. Fine. How do we get a prefix for any of the class names? It's by using the packet declaration. Okay. Fine, so we have a packet declaration to define a prefix. And yes, if we want, we can have more levels, right? So this was shapes, that was shapes.inheritance, and okay, so this is, let me call this as okay, it's being saved as where do we save it? Okay, maybe I'll save it back here, not in com, so that's more confusing, but we can save it here also, right? We can save it in okay, so we are having test keyboard.java. Okay, fine. So let's check what are the files we have got. In the source code, we have these files called account.java, okay, where no prefix has been defined. We have this class called test_keyword.java. Yeah, what's there in the, sorry, we have one called keyword.java. What do we have in the keyword.java? Oh, we haven't saved it yet, I think. Yeah. Oh, we have kept package shapes.inheritance. So this is shapes.inheritance.cuboid. Okay. And we have got cuboid. Okay. Okay, fine. So we will be getting a lot of errors now as we try to compile. Okay. But fine. Let's figure out what those errors are for. Okay. Fine. And then we'll settle the errors one by one. Okay. Make changes to settle the errors. Starting this one, fine, this is the first one which we created, and for this, in order to test this, we had the test keyboard.java. Okay. As far as rectangle is concerned, we haven't got a prefix for it. Fine. Do we go for a prefix for rectangle also? Okay, let's try that. Okay, so everything with a prefix now. Oh, this will, let's call it simply shapes. Okay, so this is shapes.rectangle. Right. Okay, let me save it where it is. Yeah. Okay, again another one here also. I think we had a test rectangle class. Let's put it into the one with the prefix test. So we will separate this out from here. Okay, and going into a separate file. Okay, fine, prefix is test, and here is, so this is okay, and we can save it as, yeah, here it can be saved as test rectangle.java. Okay, now what do we want to compile first? The shapes.rectangle is the topmost thing. Yeah, rectangle.java. This I have to save. Fine. Let's first try compiling the rectangle class. Everyone depends on the rectangle class. Okay, but it's called shapes.rectangle. There's nothing called rectangle now. Okay, what we have is a shapes.rectangle. Okay, let me do one more thing before I proceed. What I'll do is I'll delete bin, and in bin let's delete the classes. Okay, bin we can delete, those are class files, right? Okay. Yeah, I think earlier we had done for that hello world thing, we had created a package com, right? Com dot class of java dot first app, right? So we can okay, let it remain, it doesn't bother us much. Okay, now let's try compiling java c minus d dot dot backslash bin, and what we are compiling, rectangle.java. Okay, this compiles. Okay, this is compiling, and then if I look at the directory, what do I find? Oh, there's a folder called shapes. Let me see what's there in shapes. There is rectangle class. You can see because it has a prefix of shapes, a folder shapes has been created in my destination. When I compile, I give minus d, right? Minus d option specified that it should be, the class file should be stored in bin folder. So in bin, when it created the class, right, what is the class? It's not rectangle, it is shapes.rectangle, and therefore it created a folder shapes there, put the rectangle there, right? Because there could be another rectangle, right, and that may have a different prefix. So according to the prefix, it's creating the folder. Prefix is nothing but your package. So according to the package, it is creating a different folder, so that there is no name, file name does not match another one. Fine, no overwriting of file may be done. Okay, fine. So class files are getting organized for me when I compile them. Okay, fine. Let's try to compile which one? What's the next thing? Test rectangle. You want to compile test rectangle? Okay, yeah, you're going to get errors now, because in test rectangle, what have we done? We have been saying it is rectangle, but there's nothing called rectangle now. When there's nothing called rectangle. Okay, so what's the way out? We need to go to test rectangle. Okay, what is the way out? One way is, let me put shapes.rectangle. Wherever I'm saying rectangle, fine, including when I'm saying new, I'll have to say shapes.rectangle. So one option is to update this everywhere, put instead of rectangle, put shapes.rectangle. Okay. Other option is also there. Let's look at a new keyword. When we had seen package earlier, and to some extent, yes, but now we can see that we will use another statement, another declaration. So I want to declare in this here that, so we use the keyword import to declare that in this Java file, if you come across rectangle, okay, then please replace it with shapes.rectangle. In an import declaration, the last part is critical. This is what it will search for in this Java file. Okay, it will search for rectangle in this Java file, and wherever it comes across rectangle, it will be replacing with this name, whatever you have to enter. Okay, So throughout this file, yes, if you come across rectangle, please replace it with shapes.rectangle. Okay, that's what we are saying. Okay. Okay, let's compile. Okay, so we compile test rectangle.java. Okay, we get some 9 errors over here still. Yeah, it's not going to work so easily. Okay. Yeah, see, it says I don't find this thing. Maybe compile, we saw that we had this, right? But it is not able to find shapes of rectangle. Where are we compiling from? We are compiling from src folder. Where is the class shapes.rectangle? Where is the class file for that? It is in the bin folder. Okay, so you can let it know, oh, there is something called in the bin folder. I have got a class files. You don't look, see, when I'm doing this, it's looking for rectangle.java in a folder called shapes. Oh, even Java files can be put into folders over here. Or another option, let me show you different option here. Another option for me here is to say, okay, you compile test rectangle.java along with rectangle.java. Okay, I'm giving you both the files. So test rectangle, whatever you are looking for, you will find. You are looking for where is where is shapes.rectangle? It's in this. Whatever you need will be available. So, right? So you can compile multiple Java files together. Dependencies, dependent files, dependent classes, they may be compiled together like this, and let's see what happens. Yes, we are still getting errors, but now the error should be a different kind. Okay. Look at this. What does it say? Test rectangle.java, line 4. Error. What's the error? Read the error. Yeah, what is the error? Rectangle is not public. It's not now. It's not saying, oh, I don't find shapes or rectangle. Rectangle is not public in shapes. So it has recognized that there is some package shapes and there is a rectangle in that package shapes. So rectangle is not public in shapes and cannot be accessed from outside package. So it is in shapes. This is shapes.rectangle. Where are we trying to access it from? We are trying to use it from test rectangle. So we are using it from a test package. What's a package? Which is which is the other file we are compiling? Test rectangle, right? So this test.test rectangle, right, is, so it's not available in the, so these are separate packages and therefore rectangle cannot be used. You cannot use rectangle outside the shapes. Why? Because rectangle is not public. Fine. Rectangle belongs to a package called shapes. For it to be usable outside the shapes package, okay, even, yes, to use it, everyone has to know it is shapes.rectangle and not just a rectangle. But knowing name alone is not sufficient. If it is not a public class, it will not be available outside package. Okay, so let's make the change then. What is the change? We go to the rectangle class, okay, and say, oh, this is a public class. It can be even used outside the shapes package. Clear? So anything which is not public means restricted to usable only within the shapes package. So you can make it public. Fine. We just make it public and let's now check what happens. Okay, there will be still problems. Okay, but now different kind of problems. Oh, there are more errors than what was there earlier. Let's check this. What is that? And let's start with the very first error which we have got. See, you're trying to use count in test rectangle. See, it is not complaining now related to using rectangle. Fine. It is now shapes.rectangle. Okay, no problem with shapes.rectangle as a type. But now it says, oh, count, rectangle.count. When you have said rectangle.count, that rectangle is nothing but shapes.rectangle. That it has understood. Okay. Fine. So when a rectangle count has been used, it is saying, I don't find this available in the rectangle class. It cannot be used outside. See, look at that message. Count is not public in rectangle. Only if there is a public member, it can be used outside the package. And the idea is, if we have a public member, then it can be used outside the package. So if we check this out, yeah, we have the public class rectangle. Okay, so we have static int count. Now the idea here is variables, we do not normally like them to be accessible to anyone. Okay, we'll come to what access specify it should have, but we have provided this method called getCount. So even if I replace, so one option would be, yes, don't use count, but say rectangle dot getCount. But for that getCount also to be available outside the shapes package, it must be declared to be public. Okay, we declare this as getCount to be declared as public. Okay, and there where we are asking for count, we can just go for getCount. Okay. Sorry. So we go to the test rectangle. Okay, let's make some corrections here. Okay, one import, yes, we have used an import saying, okay, I need to use shapes.rectangle instead of rectangle. I have used rectangle, but it has to be treated as shapes.rectangle, right? Okay, which was the line? Count is rectangle dot. So okay, now we can switch to using rectangle dot get count. So we have the method called get count. Get count is public and therefore it is usable. Okay. First thing, the rectangle shapes.rectangle, that class is public. That's the first criteria, first thing we have to do. And whatever is public, that is what we can use. Right? Here, what have we used? Again, so this is not count. We will have to say get count. Okay. So use the get count method. Don't use any data directly. Okay. Have we been using some data directly, or that? Let's change that practice now. I think I can just, it's the same thing being repeated, and if I can just replace like this. Okay, we are replacing with get count. Okay, here, see, we didn't use dot length, we have used get length, which is the method. So that's the right thing. Okay, never use variables directly. Okay, but one thing, what will happen to this get length? Is it going to be usable? Is it going to be available? I am using it from the package test. Is get length going to be available to me for usage? Is r1.display going to work for me? Okay, let's get the errors then. Okay, we'll get some errors. Okay, there'll be the errors are going to be reduced, but we still have errors now. Okay. Oh, fine. Few errors have gone, but now you can read, see any of these error messages. If you read, it is all about access. See this display, same thing, display is not public in rectangle, cannot be accessed from outside package. So what is to be done? Okay, so normally what is the practice which is followed is that when you define a class, okay, yeah. So when you, if we are now looking at the rectangle class again, so in our class we have got variables. Okay, fine. These are the three variables we have. We have a method called getCount. Fine. Methods we normally keep them public. They will be usable outside the. They'll be usable by all. Okay. So this area method, make it public. We have been using getLength method, and everyone will use getLength. Okay. So we make this as public. Fine. Whatever we want this to be usable outside the package. Okay. Constructor. Yeah, what about this? New, and someone uses the constructor. Is this to be allowed to be the creation of by someone saying, okay, let me create a new rectangle object? Needs to be allowed even from the test or test rectangle. Okay, so it has to be allowed outside the package shapes, and therefore I put it as public. Okay. See, whatever you have written without any declaration in front of it is available only in the package. Okay. So display method, yes, we make. So methods are normally public. That is one of the things we have to understand. Okay. So normally our methods are going to be public. Okay. Let's now compile the code and check out what we have done. Oh, it has compiled. Fine. We can run the test rectangle. Java -cp dot backslash. Okay. We can check the bin folder. Oh, we can see there is a shapes was there, but now even test has come, right? Okay, and test has a test rectangle. Okay, how do I run my application? Java -cp dot backslash bin, and what's the case? What's the name of the class which has the main method? Test rectangle. And here it says I don't find test rectangle. What is it? It is test rectangle. Okay, now it's running. See, we made test rectangle working. Okay, fine. Now let me try to explain a few things. Right? Let's come to the board and we'll see. Okay. Okay, so now one thing is we use a prefix, we use a packet declaration to specify a prefix. Okay, all those classes which share the same common prefix, we say they belong to the same package. Okay, so we have classes, interfaces, enum, annotation, record. That's what we put in a Java file, and they all will have a prefix. They all belong to some package. Okay, Right? So everything in Java belongs to some or the other package. Even when we don't use a package declaration, there is a package in Java called the unnamed package. So they will go in the unnamed package. So that's also a package. We have a package called the unnamed package. Okay, fine. So if you look at the overall thing, okay, so overall it's something like this. In Java, we have got packages. So there's one package. Let's say this is a package called shapes. Okay, which has got its own members, which are classes, interfaces, enums, annotations. Right? We have got packages. Packages contains classes, interfaces, enums, and annotations. So shapes is just a name which I have written, but it's nothing but it represents a package. Any package will be there. Okay, it's not just a shapes package. So package has got members. Okay, fine. Members can be classes, interfaces, enums, annotations, records. Okay, right. So we got various packages. Okay, and packages contains members which are of type classes. Right. Now a class. So one thing here. First thing, how do we manage prefix? How do we manage? With the help of a package declaration. Okay, fine. Okay. Now, in a class definition, what we saw, we have used one thing. Okay, before going to that, yeah, one thing. Packages have members which are class, interface, enum, annotation, or a record. Each of this can have two modifiers, two access specifiers. Okay, there are two access specifiers. There can be other kind of modifiers also, but we are talking about access specifier. Access specifier refers to where this class, where this member is usable. Okay, who can use this member? Within the within the same package, if I am using another class, it will be able to use this class. But if there is some class definition, like we had the package test, and in the package test we had the test rectangle, okay, and it was trying to use the class called shapes.rectangle. Okay, shapes.rectangle was not available in test.rectangle unless we made it public. Okay, so two accessibility for member of a package. There are two accessibility available for member of a package. What are the two accessibility? We either declare it to be public or we don't declare anything. If you don't say public, that's also having a meaning. The meaning is, oh, this is a package level thing. Fine. So this is to the access of a default thing is restricted within the package. So for members of a package, okay, two access specifiers. Don't declare anything. It means package level access. Declare it public. It means it's available outside the package. Okay, fine. Okay, and then now if that member happens to be a class, okay, we know there are 5 different types of members. So we are currently looking at if that member happens to be a class, and similar to class we have enum and record. See, 5 type of members we know: class, interface, enum, annotation, and record. Okay, out of this, class, enum, and record, they are kind of class only. They belong to the category class, whereas interface and annotation, they belong to the category interface. Okay, fine. Now all members, as far as the members of a class are concerned, class type rather, class, enum or record, right? So members of a class type, they can have, now each member within a class, right? What are the members which go in a class definition? Instance variables, class variables. So we have variables, methods, constructors, and then we have nested classes, right? We just listed them. We haven't looked into what is a nested class. We have a nested, rather we'll say nested type. So within a class, again a class can be declared. Okay, fine. Interface can be declared. Enum, annotation, or record. Fine. So in the definition of class, again those could be members. So whatever is member of a class, okay, they will have 4 access specifiers. Okay, there are 4 access specifiers. Oops. Okay, there are 4 access specifiers. Fine. Which are those 4? So the most narrowest among these 4 is the private access specifier. Okay. We can make something to be private. The next one is leaving it blank. Okay, the way, whatever, see, till now we didn't know about the access specifiers and we never declared anything like public also earlier, right? Now we have started using public. That's the first thing we did. Okay, but yes, there are 4 of them. We can make something private, we can declare something to be the way we were doing earlier. Okay, and so we are not specifying anything. The third one is called protected. Okay, and the fourth one is the public. 4 access specifiers. So if a member in a class definition is declared to be private, let's say, so what would it mean? Private means usable only within that class. Outside the class, it's not available. Okay, it's not available outside the class. If we make it default the way we were keeping it, then it is available within the entire package. The accessibility will be the package. Okay, fine. In that case, see, private is, what is private? Accessible only within this class itself. Oops. Yes. Yeah. So this is private. Okay, private means accessible only within the class. Okay, if it is default, it's going to be accessible within the whole of the package. Fine. And the next level is saying protected. What does protected mean? Okay, so protected is similar to the default. Okay, it is similar to the default, that is accessibility is only within the package. Okay, slight difference is here that if for this class we have got a subclass, suppose. Okay, okay, so for this class, okay, the class which is here, if we got a subclass, maybe I have a subclass in the other package. Yeah, so if we got a subclass here, okay, so here is a class and it has a subclass. So in this class, which is a subclass, a protected member gets inherited. Okay, that is, if I have created a subclass and if I have got a protected member declared in the superclass, the superclass member, even if it is not, even if that protected member is not in the same package, right? This class here, okay, let's say this is class rectangle and I have created the class cuboid. Here is the class cuboid, right? But this cuboid is in the package called shapes.inheritance, right? We said, oh, we have a package called shapes.inheritance. So let's consider, this is not the test package, but this is shapes.inheritance package. Okay, it's a different package, different from shapes package. Here is a rectangle class and here is a class called cuboid. Different package. This says shapes and this one says shapes.inheritance. And they are separate package. Don't consider, oh, this is a sub package. No, though the prefix has a common part, but it's not the same throughout. So they have to be considered as different package. Okay. Okay. So in this case, yes, a member, if it is declared as protected, is accessible in the package. That's one thing. Outside the package, if we have a subclass, it is still not accessible. It is still not accessible. Only thing what happens is a protected member here will get inherited here also. It will get inherited. When it is inherited, this inherited member is available in this class. Okay, so in cuboid class, it is not available on the rectangle object. If someone in the cuboid class says, oh, let me create a object of rectangle and let me try to access that protected member, no, it won't be available. On the rectangle object, it's not available. It's available on the cuboid object. In the cuboid class, it is available on the cuboid object. So in the subclass, it is inherited and that inherited member is available. Okay, it won't be available on the super type. If someone is using a rectangle object in this subclass and is saying, oh, let me try to access the protected member of the rectangle class directly on a rectangle object, the idea is on a rectangle object, then it is not accessible. Okay, on cuboid it will be available. Within cuboid, fine, I'm assuming cuboid is a subclass of rectangle belonging to a different package. If it is in the same package, there's no problem. Okay, it's going to be available. Okay, clear? So what is the accessibility for? So accessibility, if I say accessibility for this protected member, accessibility is package. Accessibility is package level. Inheritance available outside the package in a subclass. Fine. So protected gets inherited even outside the package. If it is a default and someone is using a subclass outside the package, the inheritance will not be giving him the default members. Okay, from inheritance he'll not get the default member. Okay, what about public? What do you think is public? Public means it's available. Oh, it's available to everyone. Okay, fine. So fine, we think it's available to everyone. Yes, that's how it was. Okay, fine, that's how it was. Okay, from Java 9 onwards. Okay, from Java 9 onwards, there is another concept which was introduced, something called module. Okay, so what is a module? A module will be like a collection of packages. Okay, a module is nothing but it is something like a collection of packages. So you have a number of packages which form a module. Okay, fine. So now maybe you might have a module. Okay. So you might be having a module. Okay, so module will cover a number of packages, let's say. So a big thing, module is a much bigger thing. Okay, so it may be covering a number of packages. Okay, fine, but the module has its own definition where it uses a word called exports, where through which it is saying I'm exporting these packages. Module may contain any number of packages. Maybe there are more packages, but not all packages may have been exported by the module. Okay? Not all its packages may have been exported. Fine. So now, which public members are going to be accessible everywhere? Yes, if you think in terms of public is available everywhere, so not exactly. Okay, fine. Public is available everywhere only in case the module to which this package belongs, this class belongs to a package. This class has to be a public class, that is one thing. Okay, and if this public class belongs to a package which has been exported by its module, then it is available everywhere. If it is not exported by the module and it is a public member, it is available only within the module. Yeah. So module says that yes, this is a maybe this is a package which has been exported by the module. Okay, packages may have been in the definition of the module. It says I'm exporting this. Okay, so if it is exporting a module, then the public members of that are really public. Fine. Otherwise, they are restricted. A public member is restricted to module level access. Okay, so unless it has been exported, yes, it is a module level. Yes, we haven't seen what a module is, but at this moment, just for understanding purpose, you understand this public is not really public now. Okay, we have a concept of a module. Module is composed of packages. Okay, so there is module, there is package, and there is the members of a package. Okay, there's a we look at it a big hierarchy like this, right? Module levels, right? Topmost is modules, right? And then within modules we have got packages, and within packages we have those 5 different types of members. Fine. Okay. Fine. Members of package can be public. Okay. See, when we compile, we get class files. We get class file for corresponding to the 5 things: class, interface, enum, annotation. We don't get a class file for a package. It is simply a prefix for those 5 items. Fine, package doesn't have its separate existence. Okay, whereas a module has a separate existence of its own. When a module is compiled, yes, you have a separate file which is used for defining a module. Like we define a class by saying class and class name, there is a module definition. So yes, we have to use a special file by the name module-info.java. Okay. So that's a file name which is used for defining a module. And this will be using a contextual keyword called module and give a module name, and there's a whole definition. So in this, it will be saying exports and other things. I require these particular, I'm dependent, a module depends on other modules. And so it uses the word requires. This module says, okay, so when you define a module, give a module name, you say, oh, it requires, I'm dependent on these modules. So it says requires and gives a list of modules. And then it will say, oh, from my module, I'm exporting these particular packages. So it module requires other modules, it has dependent modules, and module exports packages. So in exports, it will be packages. Okay. Then, so which packages from this module are available publicly? Okay, fine. Module, we may touch upon that at a later stage, but yeah, this is clear. The meaning of the 4 access specifiers: private, default, protected, and public. Okay. Now, this is related to the class type, these 4 access specifiers. Right? We have these access specifiers available even for the interface type. Okay. In the interface type, as far as interface is concerned, okay, only for the interface and not for the annotation. Okay, something common to both of them is by default, all the members of an interface are public. So even annotation, whatever I am defining, it has only one access specifier, and that access specifier is public. Okay, fine. That is the case up to Java 8. Up to Java 8, interface type, that is interface and annotation, any member of interface or annotation was always public. Sorry. Java 9 says, okay, from Java 9 something had changed about interfaces. So only for interfaces, but not related to annotation. In case of the interface type, it says, yes, we can even have private methods. It allows for some form of private methods, but not anything like protected. Okay, so there's no protected for interface. So interface has 2 access specifiers, public or private. Right? Private only for certain kind of methods. Okay, we'll be looking at interface later, but yes, this is only related to the access specifiers. Okay. Okay. Fine. So any questions? Yes, because we covered a lot of things related to access specifier. We have introduced package. That's one thing. Yeah. We'll be continuing with this package only tomorrow also. And some few other things have been still to be done. Okay, one was the import declaration. What is that import? We used it directly, but yes, we'll see what is import, meaning of import, how exactly import is used. Yeah. I think we can continue tomorrow then with the next thing, which will be, yes, we'll be going about what is import, how it is used, and we'll in the meanwhile what you can try here is, yes, putting those, trying to put them into separate packages. Okay, yeah, one more point before we close. I think one more point, as far as these classes, interfaces, enums, annotations, the various members of a class are concerned. Uh, as far as various members of a class are concerned, okay, we have these variables, right? Normally, variables will be declared to be private. Okay, normally variables are private. If you have a static and public variable, static and final variable, sorry, you may make it public because it is a constant. Okay, but that is only for something which is primitive type, or if it is a immutable type. Okay, fine, we'll understand the meaning of immutable. Okay, but yes, if it is immutable or it is a primitive type, you may declare it as, and it is final, then you may make it public. Okay, so public static final, that's a very common kind of a declaration which is used even with something like most of the time for some kind of a constant. Right? For example, the class called math in the Java library, there's a class called math, M capital. Right? That has a variable called pi, capital Pi. Okay, fine. So this is used for storing the value of pi. So if someone wants to use the value of pi, they'll just say math.pi. It's a static variable and it is final. And a constant, fine, which is to be used by everyone. It's a constant, so no question of someone trying to change the value, right? So yes, because no one is changing the value, I have protected the things by making it a constant final variable. Okay, so making final is also a way of protecting your values. Okay, fine. So if you have protected it, right, you may want to make it public also. Someone can, in that case, yes, you are not accessing it by a method, but by a direct access to a variable. But that variable is final. Okay. So yeah, so public and so variables normally private. Okay, unless something like public static final. Okay, so variables normally private, and methods are normally public. Constructors also, you would like everyone to create object by using new. In that case, allow them. Okay, sometimes there are different kinds of design patterns which are used. Okay, fine. So there are cases where people do not like to make the constructor public, but you may like to provide a static method by which object creation can be given to others. So we'll come across such cases later, but yes. So in such cases, constructor may not have been public. Fine, but normally in the initial part, yes, you can make your constructors to be public. Okay, so fine. So whatever you have done so far, right? So in your all definitions, what you can make changes is your classes should be public. Okay, classes, all the types which you are creating, they are going to be public. So members of package public. Okay, In public, yes, we understand file name and class name has to match. Okay. And variables, make them private. Length, width, height, rectangle, in the cuboid with composition rectangle, make them all private. Methods, make them public. Constructors, make them public. Fine. Account class, yes, especially in the account class, fine. Follow all of these things. Okay. Fine. And we'll make account as part of package, so that will continue tomorrow. Okay, fine. So we break for the day, then yeah. Okay. I think it is that same exercise which is about defining the account class. We had written bank account. Huh? Okay. Fine. So have you done the exercise? Okay. Okay. So let me try to show it how it can be done. So what was the exercise? Yeah. It was about developing a class called account. Okay. So first thing, yes, we can just say class account. So, sir, yesterday I was there, so I was not working. But yeah, I can do that. So fine. The idea is a account to class account to represent a bank account. Okay. Where it should be maintaining the minimum things required for our account. Right? Each account will have an account number. Okay. So for example, yes, what were the three? We had three instance variables. We decided that we should have three variables. So one will be account number. Okay. Then a name for the account holder. Okay. And the balance has to be managed. Right? Balance we are keeping as of type long. Okay. So we decided these three variables, instance variables. Okay. Okay. We need a constructor to initialize them. Okay. So putting a constructor like this, it will take three parameters, right, to initialize the three things. So long, some account number, a string for the name of the account holder, and another long for the opening balance which he wants, right? When it is being created, he is passing the value of the opening balance. Okay, fine. So how do we go about it? It's nothing but initializing these instance variables. Okay, so this dot name equals name. Right. So the opening balance as well. I think the three things are initialized. Fine. What was the other thing? Provide getter methods for the variables. Okay. So we should have getter methods here. Okay. So for example, yes, we'll have the method to return long, method called get account number. Okay. And here we can just say simply return, okay, this dot account number. Okay, similarly, and the other two, for the other two variables also, we'll have the get methods. Okay, the third one is about the balance. Okay, fine. So getter methods, fine. And what was the next thing? No, we don't need the setters. Okay, fine. So we are not allowing someone to just set whatever value you like. Okay, fine. So the variables cannot be changed, fine, except for the balance, which will keep on getting updated. But for the updation of the balance, we'll have the methods like deposit and withdraw. Okay, so the operation of deposit and withdraw is to be done on account. Okay, fine. But before that, we have these variables to, we have getter methods for them. Next, we can have a method which will display the status of the account object. Okay, fine. So display method, yes, what should it do? System.out.println. Yeah. And what do we print here? The three things. Fine. But before that, we may just put, okay, that this is the account object who's for which we are doing it, right? The variables are for the account object. So how do I get the name account there? One option is to just say account, right? Okay. And then I'll account colon, and then I can say this dot account number. Okay. Fine. I can carry up to the next line plus comma plus this dot name. Okay. Plus another comma and this dot balance. Okay, so this is the initial version for the display. We have to think about hard coding of the name here, account. Okay, fine. Maybe we don't want hard coding. I think we have done this in the rectangle class. Yeah. Okay. So what was done? Get class dot get name. Okay. So get class dot get name plus, and then you can have all this. Okay. And so this can be what we can use in the display method. Okay. Yeah. What else? What else was asked? Method like the other methods which are to be added. Method to deposit some amount. Okay. So it will be like void deposit and takes amount as a parameter. Okay. Amount to be deposited, and this is just going to be this dot balance plus equal to amount. Okay. and the withdraw method to return Boolean value. Okay, parameter is the amount to be withdrawn. Okay, the Boolean value it is returning with the idea that if we do not have sufficient balance, okay, then it has to return false. It should not update the balance. Okay, so the first thing is check if, okay, if amount happens to be greater than this dot balance, and then it can't be withdrawn. Okay, and just simply return false. Okay, otherwise, yes, what do we do? Okay, let me put this dot balance minus equal to amount, and we still have to say return true. Okay, so this is the initial version of account. Okay, class account. Fine, clear? We have the things like instance variables, we have constructors, we have used methods. Okay, so normally, yes, whatever instance variables are there, we should have getter methods for them. Okay, we have used a method to display the current thing, whatever is there. Fine. Okay, fine. Now we can go for a class where we can test the account class. Okay, we can write code to test it. So, okay, currently I'm doing in the same file. Okay, so we have class test account. Yeah, this is only to keep the application. Yeah. Fine. So first thing, declare variables. Maybe we want to have two account objects. Fine. Create the object. Fine. So to create object, call the constructor. Okay. So constructor, yes, you can give some account number. Okay. Some name. And opening balance, right? And okay, let's see what we have, what it has created. So we'll say display, and you just call the display method and then do some operations of deposit and withdraw. Okay, and okay, each time we do something, let's always try to display what's happening. Okay, okay, withdraw returns a Boolean value. Okay, so yeah, what you could write here is you can say if not, okay, AC1 dot withdraw. Okay, so if it can't be withdrawn, right, and some amount, so maybe we try to withdraw, okay, more than what is available. Fine. So if we can't withdraw, we may like to print a message. Okay, and yeah, so here withdrawal may have taken place, may not have taken place. Fine. Even if it is, see this here in the if statement, this will be returning true or false. If it is returning false, we have this message. Okay, and if it is returning true, then also we would still like to call the display method. Okay, fine. So like this, yes, we can again try another display, another withdrawal followed by a display. So we can try another one because that's not going to return the correct thing. So here maybe we are just trying to withdraw. Okay, fine, let's withdraw 20,000 and then see the things. Okay, so like this, yes, you can just invoke those methods and test out that yes, our methods are working properly. Okay, fine, I'll save this. And so here, let's save the file as account.java. Compile and run the code. Fine, you know, right? We use minus. Okay, yeah, I think there are some concatenation is missing there. Okay, the plus is missing in the display method. So let's make the correction there. That plus, okay, string concatenation. Okay, we can recompile. Okay, so this compiles. Now we can run the code. Okay, see that name is coming as null. Yeah, yeah. So what has happened is, see, what's the name of the second parameter in the constructor? We have used n. Okay, and look at what happened. It didn't give an error from to me. When I write name, what does it mean? There's no name variable in this constructor, right? There's no parameter name by name, or there's no local variable. So what would it become? So when I'm saying this dot name equal to name, it is becoming this dot name equal to this. Okay, fine. So here, if you make a mistake, yes, this can. So let's comment this out and rewrite it. Okay. Okay, let's recompile and run the code again. Okay, so now it's coming with the proper name. Okay, so fine. So this is the first version of account class. Okay. Actually, we would like to build on this. Right? So we add a few more things. Okay. So what we want to add here is, okay, where should I put the description for the new addition? So the next step here is, in this exercise, I'm not sure why. Yesterday I think I had written the exercise, but it's not showing here. Well, it didn't get saved, that file. Okay. Anyway, so the next part is, okay, after the initial version, the next part is to add another constructor. Right, which takes only two parameters. Right? It should take only two parameters, and fine. What are the two parameters? So it takes two parameters, one for name and other for the opening balance. Okay. For account number, okay, fine. Manage, okay, such that uh, then the account number for the last account of, okay, fine. But this is applicable to the constructor with two parameters. Okay, so the point here is that yes, automatic account number generation can be there. Okay, each time you open an account, it's a new account number which it will decide based on some sequence, right? So there is some sequence which is going on. So here the option would be for a user to be able to create an account using a specific account number, okay, where he can say, okay, I want this account to be created with specific account number, or if not specified, then we have a sequence which goes on. Okay, so for this, what will be needed is you may need a static variable. Right? To keep track of the last account number. Okay, fine. So how do we manage this particular constructor so that account number can be generated automatically, right? Let's check that out. Okay, so adding another constructor with two parameters. Okay, okay, for that, yes, there'll be some other requirement also. Yes, what's the requirement we will have? We need a static variable, okay, type long, let's call it as the last account number, okay, which can have some initial value. Okay, so maybe, okay, so this is something like, oh, that was my last account number which was used, and from now onwards, if any account is to be created, it will be one more than this. Okay, so constructor for account can then be saying, okay, let's take a name. Okay, let's use the string name and long for the opening balance. Yeah, So what's the first statement in a constructor? It is either this or super, right? The first statement of a constructor is either this or super. Okay, so which one should I use? We have an existing constructor. Fine. So here we would like to invoke the existing constructor, and we'll just say this. Okay, what should be the value for the account number now? Fine. Whatever the last account number, just one more than. So we are getting that last account number incremented also with this. Okay, and we can have the name and the opening balance being passed. Okay. So, and so that's the way we can have the automatic account number generation managed within the account class itself. Okay, by using a static variable. Fine. Yeah. Okay. And then here in the class test account, yeah, let's create account number 2, account number 3, and so on. Okay. Let account number 1 be as it is, and we can have AC2 equals new account. Fine. And we will only specify name and opening balance. Okay, let's declare another. Oh, we can display it first. Okay, so here when we are only looking at 3 equals new, and okay, and AC3 dot display. Fine. We can add other invocations to deposit, withdraw, right, and then check them out. Okay, so automatic account number generation working or not? Okay, so those last two, right, those accounts which have been created, we can see it's incrementing by 1 each time and creating a new account. Okay. If someone wants, yes, he can be saying, okay, let me try creating a account with a specific account number. So maybe after this one, maybe he is saying, oh, let's have another account AC equals new account. I want a specific account number. Okay. Okay, call the display just to see what is there. Compile and run. Right? So where we have used constructor with 2 parameters, that is following a particular sequence. Okay. Fine. So if someone wants, can always be creating account with a specific account number. Okay. Right? So we have 2 options. Either you give the account number for which you want to create account, or we still can create account, right? Okay, so any questions? Okay, fine. We have learned about inheritance, right? And yesterday, I think we also were talking about composition. Did we talk about the composition thing? Okay, so what is it like? That was related to the pertaining to the cuboid class. Okay, so we have got two versions of cuboid now. Oh, I didn't create one. I didn't create the one with composition. Right. Okay, let me open the one which is with inheritance. Let's look at that cuboid class also. Yeah, this is one cuboid.java which we have. Fine. Having created a rectangle class, yes, how was the cuboid created? We said, okay, we should have cuboid as a subclass of rectangle by adding height, right? And then yesterday we just learned about the variable shadowing. Anyway, for cuboid, we didn't need this, but so if you want, you can comment it out. This was just to test the variable shadowing. Okay. Also, we have seen that method binding happens at runtime, whereas variable binding is done at compile time. Okay, fine. Like we have length in the super class, we have length here. So length is available in the rectangle class as well as in the cuboid class. Okay, so which length will be used is not dependent on what type of object we have, but it is rather dependent in the code when the compiler is compiling what is the type it has identified. Okay, so compiler identifies the type not because it has not executed the code, it doesn't know which object will be there, right? But how the variable has been declared, or have you done some typecasting? Okay, so depending on that, the length is either from rectangle or from cuboid, depending on the type, right? But when we invoke the method called area, okay, which area method will be used is dependent on the object which is found at runtime. Okay, fine. The type doesn't matter. What is the type? No, it doesn't matter, right? So it's the compiler only is doing the checking whether this method is correct or not. Fine. So now this was one which we had done, right? But this is using inheritance. Okay, so let's go for then we decided that there is a okay when we look at the relation between cuboid and rectangle, fine, we find that we can't say cuboid is a rectangle. It doesn't sound good to say that cuboid is a rectangle. Okay, so the relation between cuboid and rectangle is not is a relation, so it's not a good thing for inheritance. Okay, we have done it just as an exercise here. Okay, fine, and it helped us to understand these syntaxes of what is variable shadowing, what is method overriding, fine, use of this, use of super. Okay, fine, but no, if someone wants to design a class called cuboid, the relation between cuboid and rectangle is of has a relation, right? Cuboid has a rectangle, fine, cuboid is a rectangle doesn't sound good, and therefore we should go for composition, right? So let's see how we would create cuboid using composition. Okay, and so yeah, so here's the new version for cuboid where we use composition instead of inheritance. Okay, so yes, we still call the class as class cuboid. Okay, now it's not inheritance, so it is not going to extend from anything. Okay, yeah, then what else? What's the next thing it should have? What is a cuboid? What does a cuboid have? It has a rectangle and a height. Okay, since it has a rectangle, yes, we'll declare a variable of type rectangle. Okay, let's call the variable name rectangle, and it would have int for the height. Okay, so this is how you can have the instance variables for cuboid where it is using composition. So Rectangle and cuboid are related in this sense. The relationship has a relation now. Okay, fine. So now we can go for the constructor. Okay, so if you have to create a cuboid object, what does it need as parameters? Length, okay, width, and height also. Okay. Yeah. So how do we go about it now? Okay. We initialize the instance variables. We'll say this dot rectangle equals new rectangle. Okay, and we say length and okay, use the length and width. Fine. Use the construct of rectangle. Initialize the variable which we have. Okay, and the other is simple. This dot height is equal to height. Okay, and so cuboid constructor can be like this now. Okay, and if someone wants to keep a constructor with single parameter, and the way we had there, where he specified the value of the side where all three should be same. Okay, and so that could also be done. Okay, yeah, methods. Yeah, see the advantage here. Fine. I don't feel like having an area method for cuboid. Right? When we used inheritance, we could not avoid that. Okay? Whether required or not, or area would be, because it's there in the superclass, cuboid would always have that area. Right? It doesn't make sense to have area for cuboid, so I'm not putting the area method. Of course, we should have the getter methods. So how do we write the getter methods? Yeah. What are the getter methods you'll keep now? You want the three getter methods, length, width, height. Okay, let's see. So we have the method to return int get length. Okay, and it would simply say return this dot length. Oh, do we have this dot length? No. This dot and use the get length method on it. Okay, we have the rectangle, and rectangle has a get length method. So someone says get length. Oh, I have the rectangle. It has to be invoked on the rectangle. Okay, same way int get width. Okay, fine. Int get height. Okay, this we had, right? Now someone could also think of saying, okay, I can return a rectangle. If someone says get the rectangle for the, okay, so this could also be there. Okay, fine. So someone could use this by saying, oh, let's have a this return this dot rectangle. Okay. So yeah, next step, getter methods. What's the next thing? Okay, I would like to have the other methods. Which are the other methods? We may have method like volume. Okay, int volume. So what is volume? Fine. Area of the rectangle multiplied by this dot height. Yeah, what else? Any other method you might like to keep? Maybe method for the surface area. Okay, it's fine. You can add more methods to this, right? But you can now see that this is not much affected by what kind of methods we have in the rectangle class. That is not influencing the methods for cuboid. Okay, so cuboid decides its own methods. Fine. Okay. So if someone says display it, yeah, what do we do? Yeah. What will it be? Okay, so we normally use that get class dot get name plus okay, don't have a plus colon. Okay, and then yeah, length by width by height. Okay, we could say length by width by height. So fine, you could just say this dot get length. We don't have this dot length, okay? Plus this dot get width. And then plus this dot get height. Okay, so that's a display method. Okay, I need to save this and yeah. Okay, okay, I wish to save this cuboid class. We have a cuboid.java already, right? What do I do now? For the file name, what do I do? It's better to call it as cuboid.java only, but I can't store it here because that would destroy the earlier version of cuboid. I'm interested in keeping both the cuboids. So what is the way out? No, I don't want to call it cuboid2.java. I still want to call it cuboid.java. The name of the class is, we should have a folder, right? We can't keep it in the same folder. Okay, fine. So let's create a folder. Okay, fine. So this folder we'll call it as composition. Okay, I'll just call it in short com. Okay, fine. And in here, now I will store it as cuboid.java. Able. So with this, yes, I'm able to still call it as, I'm able to store it in the file called cuboid.java. And then what? Oh, it's in the folder compo backslash cuboid.java. And that's what I will compile. Okay, we have a spelling error.